Okay, hello my dear students, welcome back to my class. Okay, so there is a small correction for the previous class. Okay, so in place of I was supposed to write minus here. Okay, but by some mistake I wrote plus here. Okay, so you please adjust with it, and you please recorrect the whole equation. So it should be delta equal to I plus E minus A. Okay, so this should be minus, and in this expression the final, the dm expression will be minus. Okay, as even I already told you, because of I rubbed the data, that's why. Okay, I could not check it. Okay, you please do it. Okay, but overall you got the process, it seems. Okay, you can recorrect it from the textbook also. Okay, because I am using the same derivation that in the textbook. Okay, so let's start with the simple microscope. It will be continuation. Okay, so that is, as I told you, we have multiplied on both sides by what? V. Okay, so now it's V will cancel out. So I can write here 1 minus V by U equal to V by F. Okay, now I'll write minus V by U equal to minus 1 plus V by F. Okay, now multiplying on both sides by minus, so this is plus V by U equal to 1 minus V by F. Okay, so V by U equal to 1 minus V by F. Okay, now by applying the sign convention, or you can say new Cartesian sign convention. So I'll just write by using sign convention. By using sign convention. Okay, so by using sign convention, as you can see, what is the image distance? Image distance is what? D. Okay, and it is on that side. So this is in the negative side. So I can write V equal to minus D. So I'll put this, the value of image distance, in this equation. So I can write here. Okay, and as well as as you can see, object distance is what? Object distance is negative here, because again the object is on that side, means negative side. So I can write minus D divided by minus U equal 1 minus D divided by F. So minus minus cancel out. So D by U equal to 1 minus minus plus D divided by F. So D by U is nothing but magnification. So I can write M equal to 1 plus D by F. I hope it's clear now. So this is the expression for the magnification of the simple microscope when the image is formed at least distance of distinct vision, that is small m or capital M equal to 1 plus D, means that least distance, divided by F. F is what? Focal length of the simple microscope. Okay, so now we'll discuss that one. We'll discuss what? We'll discuss the same for the simple microscope, but image will form at infinity, that condition. Okay. So now let's start. So magnifying power when the image is formed at infinity. Okay, you have to write the topic, magnifying power when the image is formed at infinity. So definition is every time same, right? Magnifying power. So you have to just write the ratio of the angle subtended by the image at I to the angle subtended by the object, right, when the object is placed at least distance of distinct vision. This is very simple. Okay, you can go through it. Okay, every time the same. Okay, magnifying power definition for simple microscope, for compound microscope, for telescope, it's going to be same, just slightly different. Okay, you can get it from the book. I'll just show you the derivation. Okay, now, so again simple microscope. So it is nothing but a convex lens, right? The same. Okay, so this is focus, and here on the other side this is also focus. If you want, then you can put this F dash. Okay, now remember one thing. Okay, so when you have to get the image at infinity, you have to place the object at focus. You have to remember that, and you already know it, right? So I'm placing the object at what? At focus to get the image at infinity. So here, so since this ray is parallel, after refraction it will passes to the focus. Okay, another ray passing to the optical center. See, so it will just directly pass through it. Okay, so from here you can observe the image. Okay, now if we extend back the ray, the image will form somewhere infinity. So here I'll write from infinity, because ray will going to infinity. Okay, so but for the construction I'll place the object at LDDV. So here I can write A B object. So here. Okay, so this is B dash, A dash, A dash, B dash and BA, they are of the same measurement. Okay, their height must be same. Okay, now look here. Okay, so now, so here, say this is alpha and say this one is beta. I think it's clear. Okay, so now here, so object distance must be equal to the focal length because we have placed the object at focus. Okay, so now here I have placed this, means this is construction at point capital D. Okay, means this is the least distance of distinct vision. So I can write, so m magnifying power beta divided by alpha, means angle subtended by the image at I to the image at I to the angle subtended by the object at I. Okay, now since you have to write beta and alpha is a very small angle, so that's why m equal to, we can write 10 beta divided by 10 alpha. Is it clear? Okay, so now from the ray diagram we have to put the value of 10 alpha as well as 10 beta. Okay, now so for 10 beta we will consider say BF divided by FC. Okay, now m equal to BF divided by FC. Okay, so so for 10 beta, right, we will consider the triangle BFC, right. So from B angle BFC, or you can say BAC. Okay, because here we have placed the image placed the object at F. Okay, so I'll write here, so BF, or you can say BA. So let's write BA divided by FC, or you can say AC. So I'll write FC. Okay, so again for 10 alpha, let's assume the triangle A dash, B dash and C. Okay, so from triangle A dash, B dash by C perpendicular by base, so that is A dash, B dash divided by A dash, C. Okay, so from here let's simplify this equation. So m equal, so BA, or you can write AB divided by FC multiplied by A dash C divided by A dash B dash. But from the diagram, as I already told you, this AB must be equal to what? A dash B dash, since A dash B dash equal to what? AB. So therefore m equal to, we can write AB divided by FC multiplied by A dash C. Now in place of A dash B dash we will write AB. So now AB will cancel out. So I can write from here A dash C divided by FC. Now what is the value of A dash C? The value of A dash C is nothing but what? D. And what is the value of FC? It is U equal to what? FE, because we have placed the object at focus. So this is m equal to, so D divided by F. Okay. So dear students, from here if you use the sign convention, since both the means they are in the negative side, right? They are in the negative side, because if we measure the distance, we will measure against the direction of incident ray. So from that particular point of view, minus minus will cancel out. So again we will get the equation m equal to D by F. Okay, I hope it's clear now. Okay, so this is about the magnifying power when the image is formed at infinity. Okay, so here is principle, is everything is same. You please go through it and you just see the derivation. Okay, it's very simple. Okay, so we have done with the simple microscope. Now let's start compound microscope. So let me tell you first what is compound microscope. So again it is a microscope, so we use all these things to visualize the small objects. So compound microscope, we use this to visualize extremely small objects. Is it clear? Okay, so what is the construction? I mean, how is how it constructed, the compound microscope? Okay, compound microscope consists of two lenses. One is we call object lens. So object lens has short focal length as well as short aperture. Okay, and one is object, another one is what? Eye lens. But eye lens is bigger in aperture, means eye lens is bigger in aperture, but again it is in the short focal length. Is it clear? Both the lenses are fitted coaxially. Okay, when I draw the diagram you will get to know it. Okay, so our next topic is what? Compound microscope. compound microscope. So, dear students, here so two conditions. First, when the image is formed at least distance of distinct vision, and when the image is formed at infinity. Two conditions. First, we will start with when the image is formed at least distance of distinct vision. Okay. So, as I told you, here we have two lenses. One is called object lens, and another one is called what? Eye lens. Okay. So, this is the axis. So, this is object lens. Okay. So, you can write here object lens. Okay. So, I am just writing O. So, here, so this is F, and this is also focus. So, this is focal focus for object. So, I am writing F naught, F naught. Okay. So, here what is the principle? You have to place the object outside the focus of the objective lens here, as the name suggests objective, because on this side we are going to place the object outside the focus. So, now this is the ray parallel to the principal axis. So, it will passes through the focus. I hope it is clear. And another one will passes through the optical center, and here this is the intersection point of the two refracted rays, and here the image will form. Here the image will form. Okay. First, let us try to understand this. When we placed the object outside the focus of objective lens, the image will form at other side of the lens. Okay, between the focus and optical center of the eye lens. Okay, when I draw the diagram, we will get to know it. Okay, first, as from the diagram you can see that this is magnified. This is what? Magnified. Okay. So, now look here, this image is the real image because this is inverted. This is what kind of image? This is real image. So, since this is real image, this will act as the object for the eye lens. So, here let me draw the eye lens. So, here as I told you, eye lens is bigger in aperture, but its focal length also short like this objective lens. So, I will just write in short that is E. So, here I will write C, and this is a C dash, this is optical center. So, this image will form in between focus of the eye lens and optical center. Okay, now this is acting as an object for this one. So, the ray will reflect like this. It will, okay, I have clear. Okay, now I will extend back this ray. Okay. So, to show the image formation, let us take another ray. Okay. So, okay. So, this is another ray, and so this is the refraction. Okay. So, if I extend back this ray, say here. Okay. So, from this side you can visualize the image, and here is the image formation point. Okay. As you can see, this is working as an object for eye lens, and they are erect. Both are what? Erect. So, this is virtual. Okay. Let me do a small construction here. This is small construction. I will take this Q and this here. Okay. So, this size is equal to AB. Okay. So, here I will take this alpha, and this is beta. Okay. Now, dear students, okay, first this is the object for objective lens. So, this is going to be the object distance. Is it clear? And again, this is image for the object. This one is image for what? Objective. So, this is going to be image distance. So, I will denote it by V naught. I will denote it by this V naught because this is objective. Okay. Now, for eye lens, this image of object lens is working as object for eye lens. So, this is going to be what? Object distance. So, I will write U, but E because this is eye lens. Okay. So, we have to adjust the object in such a way that our final image will form at LDDV. So, this is the condition. LDDV means this is capital D. So, here this is AB. So, I will take this B dash, this is B dash, okay, this is B dash, and this is A dash, and again this is B double dash, and say this is A double dash. Okay. So, this is about the diagram. Okay. So, dear students, for the magnifying power, the definition is same. Okay. It is the angle subtended by the image at eye to the angle subtended by the object at eye, the ratio. Okay. So, you please get it from the book. So, I will just tell you how to derive the expression for it. Okay. So, I hope all the diagram is clear. Do not forget to give the ray and everything. Okay. Okay. Now, so that we can write m equal to beta divided by alpha. What is beta? Beta is nothing but angle subtended by the image at eye, and alpha is angle subtended by the object at eye. Okay. Now, since beta and alpha is a very small angle, so I can write m equal to tan beta divided by what? Tan alpha. Okay. Now we will put the value of tan beta from the diagram as well as tan alpha from the diagram. Okay. So m equal. So what is the value of tan alpha from the triangle? Okay, where is angle alpha? Where is angle alpha and where is angle beta? So angle alpha is here, right? So we have to consider the triangle A double dash Q and C dash. So from here, A double dash Q is perpendicular. So I'll write there A double dash Q divided by this is A double dash C. What? A double dash C. Okay. For tan beta, where is angle beta? Here is the angle beta, right? Here is the angle beta. So for angle beta, so I'll consider A double dash triangle A double dash B double dash and C dash. Okay, from here this is the perpendicular, so I can write A double dash B double dash divided by P by B. So this is the base A double dash C. Okay, so as you can see A double dash C, A double dash C. Okay, so we are taking this side, so this is C dash and this is C dash. So let's cancel out these two. So A double dash C dash will be cancelled out by A double dash C dash. So our equation will be m equal to A double dash B double dash divided by A double dash Q. As I already told you, this A double dash Q is equal to what? AB. So let's replace this value, since A double dash Q equal to AB. So I can write m equal to A double dash B double dash divided by AB. Okay. So this is the final expression. Okay, now let's modify this. Okay, let's modify this equation. Okay, let's modify this equation. Okay, so I can write m equal to A double dash B double dash. Okay, dividing and multiplying by A dash B dash. Okay, A dash B dash. This is dividing and here I am multiplying, divided by AB. So what is the point? Because if I cancel out these two, again I will get the same equation, that is A double dash B double dash divided by AB. So from here, okay, let's check this first. Let's check this one, A double dash B double dash B double dash divided by A dash B dash. Okay, first let's check the first quantity or first expression. A double dash B double dash is nothing but the image for the what? This is image for what? Eye length. So this is size of the image, and then this A dash B dash will be the size of the object. Size of the image divided by size of the object is nothing but magnification. And again, A dash B dash and AB. A dash B dash is image for the objective and AB is object for the objective lens, right? So what we can say? So this is size of the image divided by size of the object. This is nothing but the magnification, right? Magnification for the objective. So here I can write m equal to, this is representing magnification for eye lens, because size of the image divided by size of the object, into, again this is denoting the magnification for what? Objective. So I can write m, so O. Okay, so this is the expression. So from here I can rearrange the equation, MO multiplied by ME. Okay, so dear students, we will continue this same expression in the next class, means the same topic.